Assalamu alaikum wa rahmatullah. Welcome back to the fourth session of our lesson, which is oxidation and reduction. By the end of this video, you'll be able to write a balanced equation of oxidation-reduction reaction between a metal and H plus ion. The materials needed during this session are your pen and your chemistry notebook. What is an acid? Acids are compounds which dissolve in water to give hydronium ion H3O+. For example, HCl, which is hydrogen chloride, reacts with water or dissolves in water to give hydronium ion H3O+ and chloride ion Cl-. For the reason of simplicity, we can designate H3O+, the hydronium ion, by H+. For example, we can write HCl dissociates in water to give H+ and Cl-. Examples of some acids are sulfuric acid H2SO4, hydrochloric acid HCl, and nitric acid HNO3. What is common between all these acids? All these acids contain hydrogen. Then we can designate acids by HX. The general equation of ionization of an acid is HX dissociates in water to give H+ and X-. Reaction between acidic solution with metal. Do you remember what does the reaction of an acid with a metal produce? Many metals can react with acids. When this happens, the metal fizzes as bubbles are produced. Some bubbles are produced during the reaction between an acid and a metal. Look at the figure. You can see here that some bubbles are being produced during the reaction between a metal and an acid. What do bubbles mean? These bubbles produced during this reaction mean that a gas is being produced. Now, how can you test to find out if the gas produced is hydrogen gas? It is easy. We can place a burning splint next to the mouth of the test tube. Now, if a detonation occurs, a detonation means a pop sound. As the gas ignites, this shows that hydrogen is the gas produced in this reaction. To understand this idea better, look at this experiment where we add a piece of magnesium ribbon in an Erlenmeyer containing HCl solution. This is the test of hydrogen gas, where a pop sound was produced when we approached a flame to the test tube containing hydrogen gas. It is important to denote that the reaction of acid with metal is a single displacement reaction. What is a single displacement reaction? It is a reaction in which an element, which is here a metal, reacts with a compound, which is the acid, and displaces an element from a compound. In general, we can write a single displacement reaction as A plus Bx. A is the element and Bx is the compound. A replaces B in the compound to give Ax plus B. When a metal reacts with an acid, they give a salt and hydrogen gas. Always hydrogen gas is produced since the metal replaces hydrogen in the acid. Now, is the reaction between acid and metal a redox reaction or not? If yes, what are the redox couples involved in this reaction? To answer this question, look here at this practice, which is the reaction of hydrochloric acid with magnesium. In this reaction, we dip a magnesium strip in a diluted hydrochloric acid solution. Let's predict the corresponding reaction. Here the reactants are Mg, magnesium, and HCl, hydrochloric acid, which is a metal and an acid. As we know, this is a single displacement reaction where magnesium should replace hydrogen in the acid to give a salt and hydrogen gas. What is the salt? The salt is MgCl2 and hydrogen gas. It is very important to denote here that the formula of the salt must be written using the crisscross method, which we learned in the past year. Don't forget to balance the equation by multiplying HCl by 2, since we have only one hydrogen atom in the reactants and 2 hydrogen atoms in the products. Also, we have only one Cl atom in the reactants, while we have 2 Cl atoms in the products. Now, we didn't answer the question yet. Is this reaction a redox reaction or not? We have to observe the adjacent figure, then write the equations involved. Here, we place this magnesium strip in HCl solution. You can see here that some bubbles are being formed. Look at the magnesium strip. It is becoming thinner. What does this mean? This means that magnesium is being oxidized. Magnesium is losing electrons to be oxidized to form Mg2+. Also, hydrogen ions are gaining these electrons lost by Mg to form H2. Mg has been oxidized into Mg2+ by losing electrons. According to the equation, Mg gives Mg2+ plus 2 electrons. This is the oxidation half equation taking place in this reaction. Also, H plus has been reduced into H2 by gaining the electrons lost by Mg. These electrons will be gained by H plus, where 2 hydrogen ions gain the 2 electrons lost by Mg to give hydrogen gas. This is the reduction half equation, since there is gain of electrons. Now, we can see here the equation between Mg and the acid, which is denoted by H plus, gives Mg2+ and H2. Mg loses 2 electrons, then it undergoes oxidation, which is the electron loss. And H plus gains the 2 electrons to form H2, then this is the reduction half reaction, which is gain of electrons. Now, the oxidation half equation is Mg gives Mg2+ plus 2 electrons, and the reduction half equation is 2H plus 2 electrons give H2. The overall equation will be Mg plus 2H give Mg2+ and H2. Since Mg undergoes oxidation, then it is the reducing agent. And since H plus undergoes reduction, then it is the oxidizing agent. We can conclude that the reaction between H plus and a dilute solution of an acid and some metals, it is important here, some metals can make reaction with H plus, and some metals is an oxidation reduction reaction. Also, in the oxidation reduction reaction between a dilute solution of an acid and some metals, the H plus ion is the oxidizing agent and the reducing agent is the metal. In general, we can write the reaction between a metal and an acid, H plus, gives a metal ion and hydrogen gas H2, where the metal is the reducing agent and H plus, which is the acid, is the oxidizing agent. Now, what is an H plus H2 couple? In the previous examples, we have seen that the H plus ion has been reduced into H2 during the reaction with a metal according to the half equation, which is 2H plus 2 electrons give H2. This half reaction is a reduction half reaction, since there is gain of electrons. Now look at this experiment. Here, a metal reacts with an acid producing hydrogen gas. Now, we soak a filter paper with a concentrated solution of palladium chloride. Palladium chloride, it means that there is Pd2+. Now, We approach this filter paper to the hydrogen gas evolved. Look here, we approach this filter paper which is soaked with palladium chloride to the hydrogen gas which is evolved in this reaction. Now look here what happened. This filter paper, we have a brown deposit on it. There is a brown deposit of palladium on this filter paper. What does this indicate? This indicates that the hydrogen gas which is produced in this reaction is being oxidized into H plus ions during the reaction with Pd2+, forming palladium. This means that hydrogen gas is being oxidized into H plus ions by losing 2 electrons. This half reaction is an oxidation half reaction since there is loss of electrons. What does this show? This shows that the two species H plus and H2 form an oxidation reduction couple which is indicated by H plus H2. Since H plus undergoes reduction to form H2 and H2 undergoes oxidation to form H plus. They are related by the half reaction. 2H plus gains 2 electrons to give H2, or H2 loses 2 electrons to give H plus. Summary of this lesson: the redox couple of hydrogen is represented by H plus H2. The half reaction of hydrogen couple is 2H plus 2 electrons gives H2, and the reaction between metals and acids is represented by a metal plus hydrogen gives Mn plus H2. Hydrogen gas produces a detonation or a pop sound in the presence of a flame. This session was prepared by teacher Anfal Yassin, recorded by Mr. Mustafa Tlais, and supervised by teacher Hiba Badawi. Thanks for your listening.